Hi Year 10s. In today's lesson, you will learn how to solve equations using the method of completing the square. You might remember completing the square from algebra last semester. Before we start, I just want to consider factorising these expressions. If we look at the first one, I'm looking for two numbers that multiply to the end but add to the middle. So two numbers that multiply to 15 but add to 8. So those two numbers would be 5 and 3. So we put them in the brackets, x plus 5 and x plus 3. If we're looking to factorise the second expression, we're doing the same thing. We're looking for two numbers that multiply to give the end and add to give the middle. So we're looking to multiply to 25 and add to 10. So those two numbers are going to be 5 and 5, because 5 times 5 is 25 and 5 plus 5 is 10. But if we look at this last expression here, I'm looking for two numbers that multiply to give 1 but add to give 6. So the only things that multiply to give 1 are 1 times 1, but 1 plus 1 does not equal 6. Therefore, with this expression, we must complete the square in order to factorise. This is the formula we follow to factorise by completing the square. I'll get you to copy this into your books, and on the next slide, I'll explain what each part means. This is the formula to follow to complete the square. If you follow this exactly, you should get it right every time. The first step is to figure out what half of b squared equals. So b is the middle part of the expression. Once we've done this, we add half of b squared and subtract half b squared from the equation. We do it in the middle where I've indicated. Next, we factorise the first part of the expression and simplify the end. So when factorised, it will be two brackets that should be the exact same, and simplifying the end, we're just adding or taking away the numbers at the end. Then, because the bracket should be the same, we can rewrite it out like this. And the last step is to factorise using dots that will look something like this. We'll do another example. So my first thing to figure out is what half of b squared equals. So b in this case is 8. So 8 divided by 2 is 4. 4 squared is 16. So I need to add 16 and take it away in the middle of this expression like so. So plus 16 minus 16 minus 3. Then I factorise this first section here. So two numbers that multiply to give 16 and add to give 8. 4 and 4. Then I simplify this. So minus 16 minus 3 minus 19. So then I can rewrite it out like this. X plus 4 squared minus 19. Then I factorise using dots. So my first bracket is the x plus 4, and I'll have plus square root 19. Then I'll have x plus 4 take square root 19. So now we know how to factorise. The next step is solving. So the first thing we do is we complete the square, like I've just shown you. Next, we use the null factor law. And lastly, we solve for x. As you can see, we use the exact same steps, but this time we just set it as equal to 0. Let's try this example. So first I need to factorise by completing the square, which means I need to find half of b squared. B in this case is 6. 6 divided by 2 squared. 6 divided by 2 is 3 squared, which is 9. So now I need to add that and take it away in the middle of the expression. Then the next step is to factorize the first part. So I'm looking for two numbers that multiply to give 9 but add to give 6. So that'll be 3 and 3. And next I need to simplify the end. So negative 9 minus 11 is negative 20 equals 0. I'm just going to rewrite this out. So I've got the two brackets, x plus 3 squared minus 20 equals 0. Then I factorize using dots. So I've got, in the first bracket, I've got x plus 3 plus the square root of 20. And the next bracket is x plus 3 minus the square root of 20 equals 0. Now what I'm going to do is use the null factor law. So I'm going to set each part equal to 0. So I've got either x plus 3 plus the square root of 20 equals 0, or x plus 3 minus the square root of 20 equals 0. And then the last thing I need to do is solve for x. So with this first one here, the opposite of plus 20 plus the square root of 20 is minus the square root of 20. So x plus 3 equals minus square root 20. And then next step with the inverse operations is minus 3. So I've got x equals negative 3 minus the square root of 20. Or our other one, the opposite of minus square root of 20 is plus the square root of 20. So I've got x plus 3 equals square root 20. And the inverse of plus 3 is minus 3. So I've got x equals negative 3 plus the square root of 20. There it is, solved. I'm going to go through one more example. This one we need to be careful with negatives. Be careful with negatives. Okay, so the first thing I'm going to do is find out what half of b squared is. In this case, b is negative 4. So I've got negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared, that means negative 2 times negative 2. That makes positive 4. So I'm going to add that and take it away in the middle of the expression. X squared minus 4x plus 4 minus 4 plus 2 equals 0. Now to factorize this first part. So I'm looking for two numbers that multiply to give positive 4 but add to give negative 4. So that's going to be x minus 2 and x minus 2. Next I simplify the end. So negative 4 plus 2, that's negative 2 equals 0. Then I'm going to rewrite this out. So I've got x minus 2 squared minus 2 equals 0. And now I factorize using dots. So the first part of the bracket, I've got x minus 2 plus the square root of 2 and x minus 2 minus the square root of 2 equals 0. Now I can use the null factor law, which states that either of those factors equals 0. So I've got either x minus 2 plus the square root of 2 equals 0, or x minus 2 minus the square root of 2 equals 0. And the last step is I solve for x using inverse operations. So the opposite of plus square root of 2 is minus square root 2. So x minus 2 equals minus square root 2. And then I'm going to plus 2. So x equals 2 minus square root 2. I always put the square root part at the end of the expression. It makes it a bit easier to read. Then our last one here, the opposite of minus square root 2 is plus square root 2. So x minus 2 equals square root 2. And the last step here, I've got to plus this 2 to the other side, which leaves me with x equals 2 plus square root 2. So these are the textbook questions I want you to do. There's only 4 of them. Just be aware that the textbook solutions may look a little different. They actually simplify a little bit further using a method we don't do until later on in the semester.